is, so yesterday we studied examples of probability. We understood what the concept of probability. So page number 59, and aim of today's lecture. Aim of the first lecture, to understand probability distribution, and then what are the different types of probability distribution, and then in second lecture we'll start with the binomial distribution. In third lecture we'll study the Poisson's distribution. In the fourth lecture we'll study the normal distribution. Okay, like this. This is our aim. Okay, so let me start with the probability distribution. Right. Probability distribution. Okay, below that, right now, sample space. Collection of all possible outcomes of an experiment is known as collection of all possible outcomes, random variable. Next definition, that on random variable. A variable whose value is a number determined by outcome of experiment. Is known as probability function. Suppose X is a random variable with values x1, x2, and so on. Then f of x1, f of x2 are values of x at x equal to xi. Then suppose Pi is probability associated with xi, then the set xi pi, x and corresponding random variable and corresponding probability, is known as probability distribution function, or probability density function. एक spin होकर okay? Probability distribution or probability density function. For example, consider an experiment of tossing a coin, single coin. Okay, so sample space. What is sample space? What are the possible outcomes? Head and tail. Okay, now let me define the random variable. Okay, so random variable. Define random variable as, you can write it this way: x number of heads. This is experiment that I am defining. Okay, so what are the different possibilities for x? How many heads may be there? 0 or 1. Right now we may have 0 head in case of tail and single head in case of h. Okay, now what is probability of x equal to 0? Probability of 0 heads, half. What is probability of 1 head? Yes, half. Okay, then probability distribution function is, it is like this. X probability of x, 0 and 1, half, half. Hope everyone is getting this. Jepten is around?
Oh, sir.
Okay, we will take one more example so that it will be clear. Can I change the page? Let me change it. All right, second example. Right. Consider an experiment of tossing 3 coins simultaneously. Please complete it. The sample space. Yes, what are the possible outcomes? These are the outcomes. Head, head, head. All the coins show the head. Okay. What is second possible outcome? Head, head, tail. 2 heads. Head, tail, head. Tail, head, head. Okay. Next possible outcome. Say head, tail, tail. Tail, head, tail. Okay. Then tail, tail, head. And then tail, tail, tail. How many outcomes, possible outcomes are there? 8. Okay. Now we want to define x. Different ways are there to define the x. So we can say number of heads, number of tails. Okay, for example, let me consider number of heads. Yes, what are the different possibilities for number of heads? Number of heads may be 0, maybe 1, maybe 2, or maybe 3. Okay, let me write it here. So how many heads we have here? 3 heads, 2 heads, 2 heads, 2 heads, 1 head, 1 head, 1 head, 0 head. Right? 3, 2, 2, 2, 1, 1, and then 0 head. Now we want to write the probability. Right? Probability of 0 heads. Yes. How many times we have 0 head? Single only. Out of how many total events are there in the sample space? 8. Now, probability of one head. How many times we have one head? 3 times. Out of how many? 8. Now, probability of two heads. These are the two heads. 1, 2, 3. Okay, so 3. Out of how many? 8. Probability of 3 heads. 1 by 8. Okay, so hope everyone is getting this. Probability distribution function like this. X, probability of X. 0 heads. X is the random variable, and what is that? Number of heads. So you might have observed that if we add all these numbers, what is their addition? 1. Maximum probability is 1, na? So addition will be 1. Clear? Understood? Hope this is clear to you. Okay. Next item. Next concept. One minute. I'm audible now? I'm audible
Yes.
to you?
Sir.
Okay. Right now. Mathematical expectation. Right. Consider probability distribution function as x and p of x. Then expected value or mean value of x is denoted by e of x and given by x1 p of x1, x2 p of x2, and so on. xn p of x. Right? That is, in short, it is given in this way. xi p of xi. Hope this is also clear. Next letter. Next page. properties of the expected value. E of x is arithmetic mean. Arithmetic mean is denoted by x bar or mu. These are the two notations. Mu is also notation for arithmetic mean of random variable x. So E of x equal to x bar equal to mu equal to summation of xi p of xi. Okay, remember this. Second, right, variance of x, right, variance of x equal to sigma square. We know this. How it is obtained? Expected value of x square minus expected value of x whole square. Okay, now what is meaning of this? That is like this. Equal to hope you remember expected value of x, summation of xi p of xi, right? And then it's square. Now what is e of x square? It is like this, summation of xi square p of xi. Xi square p of xi, or you just write p of I, that is also sufficient. Hope all these things are clear. Okay. So example. Okay, we'll go through this example. Right. One. A die is thrown. Twice. X denote the sum of digits in two throw. Find mathematical expectations. Right. Sample space when two dice are thrown. DI C लिहितात ना हे? चेक करत म्हणजे. Yes.
Yes, sir.
1 1 1 2 1 3 1 4 1 5 1 6. first. Not required. If you know, you can write it directly also. Okay. I am writing sum, huh? It is 2 here, 3 here, 4 here, 5, 6, 7, 8, 9, 10, 11, 12. Okay, these are the sums. But how many events are there? I'm writing them in circle. 1. How many favorable outcomes are there? So 2, 3, 4, 5, 6. Now it will start decreasing. 5, 4, 3, 2, 1. Getting na? Getting everyone na? So the value of random variable, these are the values of x. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And corresponding probabilities for the first 1 divided by 36, second 2 by 36, 3 by 36, 4 by 36, 5 by 36, 6 by 36, 5 by 36. Getting everyone? Okay. So let me continue on the next page. Sum of 2 digits. Probability distribution function is sum is 1 is not possible, no? 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. These are the different possibilities for the sum. Okay. And what is probability that we will get 2? 1 divided by 36. 2 divided by 36. 3 divided by 36. 4 by 36. 5 by 36. 6 by 36. Now again 5 by 36. शायद सबको समझ में आ रहा है हम क्या कर रहे हैं. Right? Now expected value. So 2 into 1 by 36 plus 3 into 2 by 36, 4 into 3 by 36. अब बाकी लिख दीजिए 12 into 1 by 36. So add and tell me what is the expected value. Isn't it? Arithmetic mean. Hope everyone is getting all these things very well. चलो आगे बढ़ते हैं. Any doubt? आप कुछ बोल नहीं रहे हो आज? Any doubt?
No, sir.
Okay. But see, one observation, you might have observed one thing. Whenever we are considering the value of random variable, right? If you consider previous example or this example, see what the values are. It is 2, 3, 4, 5, 6. So we are not considering any value between 2 and 3. Right now? Not considering any value between 2 and 3. Not considering any value between 8 and 9. Right? So many values are there between 2 and 3. No? So 2.5, 2.55557, okay, 2.0000089. So infinite number of values are there between 2 and 3, but we are not considering them. So whatever distributions we consider till, they are known as discrete distributions. Okay, so right, discrete distribution. Random variable x has only integer values. Then distribution is known as discrete distribution. Okay, let me go to the next page. 63. Right. When the random variable has all values in an interval, the corresponding distribution is known as continuous distribution, and probability distribution function is known as probability density function. Probability density function. Now, what is PDF that will define? The probability density function f of x is such that, right, 1, f of x is always greater than or equal to 0 for all x belongs to set of real numbers. F of x is always greater than or equal to 0. And important property, integration of f of x dx over whatever the interval is, should be equal to 1. Note, right, probability in an interval, say, is defined as, now how probability is defined here? Probability means like this, integration of f of x dx from where to where? A to B. That's it. This is the probability. Examples. For given PDF you understand, na? Probability density function. Find K. Our aim is to find K. K into e raised to minus alpha x. For x greater than or equal to 0 and alpha greater than 0. Otherwise. So one important property of probability distribution function is known to us. Okay. What is the property? Second property. See this, integration of f of x dx equal to 1. Okay. Right. Since integration of f of x dx equal to 1. For what the interval? Minus infinity to plus infinity. Okay. So let me divide the interval in two parts. Minus infinity to 0. Okay. And then 0 to infinity. And answer is 1. What is the value in what is the value of the function in minus infinity to 0? Otherwise means for x less than 0. Na? This is for x greater than 0. Otherwise means for x greater than 0. So what is value of f of x here? 0. What is value of f of x here? K e raised to minus alpha x. Getting anyone now? So on the next page, the first integral will become 0, whereas second integral we have to substitute f of x equal to k e raised to minus alpha x. And from there we have to find the k. Okay, let me continue. Getting everyone now? Nothing difficult. Huh? Be confident. So 0 to infinity, काय होतं k e raised to minus alpha x dx equal to 1. upper limit infinity, lower limit 0. E raised to minus infinity 0, e raised to 0 1. K equal to alpha. Getting everyone? Okay. This is all about the probability distribution. Okay. Then madam, discrete distribution. Or better right here, our aim is to study, right, a part, discrete distribution. Inside that two parts are there, right? Binomial distribution. Second, right, Poisson's distribution. And that B, continuous distribution. Right, one. Normal distribution, right? Many are there, but here we have to study these only. Taste distribution. Taste distribution means whenever we want to taste something, whenever we want to taste our claim, yes, I will pass the engineering mathematics 3, whether exam will be in online mode or offline mode, doesn't matter. This is claim. This is known as null hypothesis and alternate hypothesis. Okay, what will be H1 now? Alternate hypothesis. Exam may be in online or offline mode. It is clear that I will fail the M3, right? So whenever we want to test this type of claims, then we have to use taste distributions. Many are there. ANOMA distribution is there. T distribution is there. Okay, and here we want to study the chi-square. Chi, this is notation for chi. Chi-square distribution. Okay, we'll start with first one. We'll have a break of 2 minutes. You have to stay here. Don't leave. Break for me, not for you. Okay. Don't break. And we'll start with the binomial distribution. That will not take more time.